Hi. Hi dear students, welcome to Get Wallah. This is Satish Kumar Durishetty, faculty of Measurements and Instrumentation. In our electrical measurements, we are here to lecture number 4, measuring instruments. So what are the topics that we are going to discuss? Let us have a full discussion. In the last class, we have started the PMMC PMMC in detail. We have discussed the deflection torque and control torque expression, and we have seen the range extension also. Okay, so today also we'll continue those topics. So measuring instruments like problems on PMMC, moving iron, dynamometer, and if possible we'll discuss the measurement of power, measurement of energy, so these are the topics that we are going to discuss. So in the last session we have a glimpse of all the formulas. So we are having the glimpse of all formulas. Let me write about all the formulas first. So what are the formulas we have discussed in the last class? You see the list of the formulae. Okay, so for PMMC, what are the list of the formulas? Let me summarize, because the summary is most important for us. So if you see the PMMC, permanent magnet moving coil, permanent magnet moving coil. Let us see this topic once again. All of you, just whoever joined, just give me the confirmation. What are the formulas? So if you see the deflection torque formula, that is bina, and controlling torque formula, that is Kc theta. So theta is proportional to I. So these are the torque expressions. Next, ammeter, RSH is equal to Rm by m minus 1, where m is equal to I by Im. Next, RSC is equal to Rm into m minus 1, where m is equal to V by Vm. So these are the basic formulas. Okay, so like this we are having a list of formulas, dear. So you have to understand the list of formulas. Similarly, can you type what is the moving iron instrument formulas? Moving iron. For moving iron, what is the formula? So if you go for moving iron, so for moving iron instrument, the deflection torque 1 by 2 I square d L by d theta, controlling torque formula Kc theta. So theta is proportional to I square. So which is possible for DC as well as AC measurements. Okay. Next, if you see the range extension of the ammeter, MI ammeter, moving iron ammeter, if you see, the moving iron ammeter, we are having this first, it is a inductance oriented device, so it is having LM, and in addition to the meter resistance is also having the inductance. So this is our IM. So in parallel, what we should have, so we are going to attach LSH, RSH. So this is the I, this is the ISH, and this is the IM. So here the time constant of the meter, time constant of the shunt coil must be same. So we can type LM by RM, and this I can write LSH by RSH. Okay, these are the basic things. So if you choose like that, then the meter resistance RM is equal to RM by M minus 1 here also. आएंगे. So here, where M is equal to I by IM. Similarly, if you take the moving iron range extension as a voltmeter, So these are the important formulas. So what I mean here is these are the important formulas. So range extension as moving iron voltmeter. Check the range extension of moving iron voltmeter. So what I can use here, so this is our IM, this I can take this as LM, my RM, and in series we can keep RSC. Okay, so this is our IM. This is our VM, and this is our V. Got it? So how to do this? Now if you check, the VM can be taken as I into Zm, which is square root of Rm square plus omega Lm whole square, whereas capital V is can be taken as I square root of Rs plus Rme square is omega. So these are the formulas. So we can take the ratio and we can establish a formula here. So capital V by small Vm, capital V by small Vm equal to I square root of Rm plus Rsc whole square plus omega Lm square divided by Im is Rm square plus omega Lm square. So this is gets cancelled. So V by Vm, if I take, this is the expression. Okay, so we can use all these formulas in calculating the range extension of the voltmeters. Okay, next similarly, if we go for some numerical questions here on this, try to answer this question. Check this question, what is the answer for this? The inductance of a certain moving iron ammeter is expressed as L is equal to 10 plus 30 theta. Theta is not printed here. So this is 30 theta So we can write it as 30 theta minus theta square by 4 microhenry, where theta is a deflection in radians from the 0 position. The control spring torque is 25 into 10 power minus 6 Newton meter per radian. The deflection of the pointer in radian when the meter carries a current of 5 amperes is dash. So how to solve this? If you want to take this, the self-inductance expression is given as 10 plus 30 theta minus theta square by 4. So first of all, let us calculate the dl by d theta. So this will be 0, 30, this is minus 2 theta by 4. So it will become theta by 2. So what I am going to get is 30 minus theta by 2. So this is the dl by d theta expression. So from this, the deflection torque we can calculate. Deflection torque is equal to 1 by 2 I square dl by d theta, and the controlling torque is kc theta. So this controlling torque is given as 25 into 10 power minus 6 Newton meter per radian. So this I can given as 25 into 10 power minus 6 Newton meter per. So this is the controlling torque. So at steady state, deflection torque is equal to controlling torque. So for a moving iron, I can write 1 by 2 I square dl by d theta is equal to this kc theta, that is given as 25 into 10 power minus 6 Newton meter per radian. Okay, so if you see this, 1 by 2 I square dl by d theta is equal to 25 into 10 power minus 6 Newton meter per radian. Okay, so here what is available for us? I think he is asking, the current is given as 5 amperes, the control spring torque is given, the deflection of the pointer in radian he is asking. So first of all, let us write the dl by d theta, 30 minus theta by 2. Am I right? So derivation of this constant 0, 30 minus theta by 2, right? So of I square, I is equal to 5 amperes. So this is 1 by 2, I square means 5 square. Dl by d theta I can give it as 30 minus theta by 2. So this is 30 minus theta by 2, and this can be taken as 25 into 10 power minus 6. Okay, so this 5 square and 5 square gets cancelled. Actually this dl by d theta you have to observe, this is given in microhenry, so here there will be 10 to the power minus 6 also here. So this 10 to the power minus 6 also gets cancelled. So now we can write 15 minus theta is equal to 1. What I am going to get? The deflection of the pointer is asking, right? Any mistake we have done? Theta by 4. By 2 I square 25, this dl by theta is equal to 30 minus theta by 2, that is also correct. 10 power minus 6, 10 power minus 6 cancel, 5 square, Answers are not matching. Asking the deflection of the pointer in radian. To check this expression, I think there is a printing mistake in the expression. Check that expression once. '64 is coming, na? 64 is coming. Answers are not matching. We have to check this answer. Please try to check these options once again. Answers are not matching. Cancel, these answers are not matching. As per the methodology, these are right answer. Next, let us go for one more question. So IIT Delhi 2004 का सवाल. Let us see this question. A moving coil of ammeter has a 100 tons length, 100 tons it has given. So a moving coil of a meter has 100 tons, length and depth, that means area, that means 10 into 10 to 10 power minus 6 meter square, 10 into 20 is 10 into 20, 10 mm cross 20 mm, na? 10 mm cross 20 mm. So this will be 200 into 10 power minus 6 meter square. So this area. Flux density B given as 200 millitesla, 200 into 10 power minus 3 Tesla. Coil carries a current of 50 milliamperes, so current is given as 50 milliamperes. The torque on the coil is asking, so he's asking the deflection torque. So directly we can use the formula, deflection torque is equal to B now. So that's B is given as 200 into 10 power minus 3 and current is given as 50 milliamperes, 50 into 10 power minus 3. Number of turns is given as 100. Surface area is given as 200 into 10 power minus 6. So answer will be 10 power minus 3, 1, 1, 2, 3, 4, 5, 6. Next 20 2 ja 40, 45 ja 200. So 200 micro, 200 into 10 power minus 6 Newton meter. So is 200 micro Newton meter is the answer. Option A is the right. Let us go for the next question. Try to answer this question. A moving iron ammeter produces a full scale torque of 240 micronewton meter. So what is the data given? Produces a full scale torque of 240 micronewton meter with a deflection of 0 to 120 degrees. With a deflection of 0 to 120 degrees with a current of 10 amperes. The rate of change of self inductance is asking, that means dL by d theta is asking. Of the instrument at full scale is asking. Full scale means at full scale theta is equal to 120 degrees. Semendra. So how to solve this? So we can write as Td is equal to 1 by 2 I square dL by d theta, the expression. Asking here I think is directly asking 240, na? So we can substitute the values here. Deflection torque is 240 into 10 power minus 6. This is 1 by 2 I square, that means 10 square, and this is dL by dt. Okay, so 480 4 minus 80 dL by 48 into 10 power minus 7, so 4.8. Now ready అయిపోండి, get ready. 4.8 బయటికి వెళ్దాం, dL by d theta. Okay, so very good questions, quality questions. Next. How to answer this question? Whoever watching in the session, try to answer these questions. How to answer this question? A periodic voltage. In the question he has given a periodic voltage waveform observed on oscilloscope across a load is shown. A permanent magnet moving coil meter connected across the same load refers to its dash. So this type of waveform related questions are given. So how to solve this type of waveform related questions? So we know the average. So V average can be taken as area under the curve the total time. So area under the curve is, this is half VH plus at the bottom this is the rectangle, so this is minus 5, this is 2 and this is minus 5. So minus 5 into 2, next this is 8 into 5, and if you see the total time 20. Okay. So now if you calculate how much you are going to get, check it. 40 minus 20, 20, 50, 100 by 2, 50, 50 minus 10, 90, 130, by 20. So you are going to get 4 volts, sorry, going to get 50 plus 40, 90, 90 minus 10, 80, 80 by 20, 4 volts. So what actually I am going to get is 4 volts. Okay, so let us go for one more question. How to solve this question? Very interesting. So how to solve this question? This question is from IIT Kharagpur 2014. The DC current flowing in a circuit is measured by 2 ammeters. One is PMMC and another one is electrodynamometer type, connected in series. The PMMC meter contains 100 turns in the coil. The flux density in the air gap is 0.2 Weber per meter square and the area of this coil is 80 mm square. The electrodynamometer ammeter has a change in mutual inductance with respect to deflection of 0.5 millihenry per degree. The spring constants of both the meters are equal. The value of current at which the deflections of the 2 meters same is. So how to answer this question? So this question is related to both. One is the PMMC, other one is the dynamometer. So the DC current flow in a circuit measured by 2 ammeters. One is PMMC, and other one is dynamometer. One is PMMC, other one is dynamometer. So if you see the PMMC expression, we know for PMMC the deflection torque is beta, controlling torque is equal to Kc theta. So beta is equal to Kc theta. So theta is equal to Bna by Kc into T, Kc into I. Dynamometer, if you see, the deflection torque is I square dm by d theta. It works on the mutual inductance concept, and controlling torque is Kc theta. So here Kc theta we write this is I square dm by d theta is equal to kc theta. So theta is equal to I square by kc dm by. So what is getting, just to try to understand in the question, he is comparing the two meters, one is a PMMC, other one is a dynamometer. The DC current flowing in a circuit is measured by two ammeters, one is PMMC and another one is a electrodynamometer type connected in series. The PMMC meter contains 100 turns, okay, flux density, okay. So what is the data he has given, check it. So he has given the 100 turns. He has given this as 100 tons. Flux tons in the air is given as 0.2 Weber per meter square. And the area of this coil is given as 80 mm square. Okay, everything is given. The electrodynamometer ammeter has a change in mutual inductance with respect to deflection 0.5 millihenry per degree. So this dm by theta is given. The spring constants of both the meters are equal. So this and this both are equal. The value of the current at which the deflections of the two meters are same. So if the deflections are two same, then what happens? The first deflection, which is equal to BNA by KC into I, that should be equal to I square by KC into dm by d theta. So as he mentioned, the KC's are equal, this gets cancelled, one I also gets cancelled. So what is the I is asking, that is a BNA divided by dm by d theta is equal to I. So from this data, the B is given as 0.2. So this B is given as how much? 0.2. And the number of turns is given as 100. And the area is given as how much? 80 mm square. That is 80 into 10 power minus 6. And the dm by d theta he has given as 0.5 millihenry per degree. So this is 0.5 into 10 power minus 3. If you simplify, how much we are going to get? Check. 1, 2, 3, 3, and this also gets cancelled. So now this is how much we are going to get? I is calci use करके I. So this is 2 by 10, 16 by 10, 16 by 10, 3 point something. Going to get 3.2, 16 by 5, 3.2 amperes we are to. Okay, so these are the questions. Any other doubts? You can ask me. Anybody is having any doubts, you can post here. Any other doubts related to subject also, you can post here. Hello. Let us move for the next question. Try to answer this question. Looks simple, but you should have some common sense. Match the following as given. Option A, permanent magnet moving coil. Sorry, P. So this is the instrument type he has mentioned. The instrument type, and this is used for. So one is the application, other one is the instrument type, and this. If you see instrument type P, permanent magnet moving coil, moving iron connected through current transformer, rectifier, electrodynamometer, used for DC only, AC only, and AC and DC. So how to solve this? So if you see, PMMC is going for only for DC. So PMMC is only suitable for DC only. Next, moving iron connected through current transformer. So that is only for AC. When you are giving current transformer, actually moving iron will be AC, but DC. But moving iron with current transformer he has mentioned. So compulsory it should be AC only. Next, rectifier. Rectifier can be suitable for both AC as well as DC. AC as well as. Next, electrodynamometer. Electrodynamometer is both for AC as well as DC. So permanent. So P goes to 1. P goes to 1. Moving iron connected through AC only, Q goes to 2. R and S both are goes to 3. R and S both are goes to 3. R, AC, and also S. So 1, 2, 3. So P goes to 1. Q goes to 2. R and S. R goes to 3, S. So these are the questions. So what is the answer for this question? A sawtooth waveform shown in the figure is fed to a moving iron voltmeter. So for moving iron, the measurement will be RMS. So generally VRMS will be what? VRMS will be nothing but, for a triangular wave it is Vm by root 3. Vm by root 3 for triangular waveform. For a triangular. So the answer will be 100 by IIT Guwahati question 2018 का सवाल. How to answer this? Huh? A 0 to 1 ampere moving iron ammeter has an internal resistance of 50 milliohms and inductance of 0.1 millihenry. A shunt coil is connected to extend its range to 0 to 10 amperes for all operating frequencies. the time constant in milliseconds and resistance in milliohms of the shunt coil respectively or dash. So this question is related to what? This question is related to moving iron. This question is related to moving iron instrument. How to do it? So first of all, let me draw the moving iron diagram. So what is a moving iron diagram? The moving iron diagram will be like this. This is IM, this is LM, this is RM. This is LSH and this is RSH. This is our ISH. So what is the data given? A 0 to 1 ampere moving iron ammeter. So 0 to 1 ampere. So this is maximum is 1 ampere. So this is 1 ampere. 0 to 1 ampere. Internal resistance of 50 milliohms. So this is 50 milliohms. And inductance of 0.1 millihenry. So this inductance is 0.1 milli. A shunt coil is connected to extend its range to 0 to 10 amperes. So he wants to extend the range to 10 amperes. For all operating frequencies, the time constant in milliseconds and resistance in milliohms. So first of all, we don't know the shunt resistance and we don't know the LSH respectively or dash. He is asking how to do this question. Okay, so we can do now. Time constant of the meter and time constant of the shunt must be same. So from that we can solve some information. Yes or not? So generally we have to choose a shunt component such a way they should match with the time constant of the tau m must be equal to tau sh. So this is Lm by Rm. This is LSH by RSH by R. Okay, so from this what we should do now? Lm by Rm is equal to LSH by RSH. So for all operating frequency means it should work for the DC also. So for all operating frequencies when we mention, so we can say DC frequency also should work. So for all operating frequencies it should work. For all a frequency to work means RSH can be taken as a formula Rm by m minus 1. Rm by m minus 1, so which is Rm by I by Im minus 1, because it should work for DC. So omega component gets cancelled. So from this, first of all, we can find out the RSH. So what is the meter resistance? The meter resistance is 50 milliohms. So this is 50 into 10 power minus 3, and the capital I, that is 10 amperes, is 10 amperes by Im. What is Im? Is 1 ampere minus 1. So 50 by this, 50 by 9, approximately how much? Use the calcium and tell me. 50 by 9. $5.55 milliohms. So we got this. Now we know the Lm and Rm, so we can find out the time constant. Okay, so Lm is equal to how much? Lm is equal to 0.1 millihenry. 0.1 millihenry. divided by Rm. This is 50 milliohms. 50 into ohms. LSH we don't know. RSH 5.55 milliohms. So this cancel. So we can get LSH 0.1 divided by 5. So LSH is coming as 0.0111 millihenry. So this is a LSH value, this is a RSH value. He asked us the time constant and resistance. So time constant is Lm by Rm. So here itself we can find out time constant. Lm by Rm. Find out the time constant Rm. 0.1 divided by 50. Going to become 2 milliseconds. Are the answers. So we got the time constant, we got the shunt resistance 5.55, 2 milliseconds. So the right answer is option. Very, very good questions, quality questions. Don't miss these questions. Hope got it. Next. IIT Kanpur 2015 question. A 0 to 50 amperes is asking the external shunt resistance. IIT Kanpur 2015 question. 0 to 50 amperes. So if you see, this is the IM 50 amperes. Moving coil ammeter. Okay, moving coil ammeter. Moving coil ammeter has a voltage drop of 0.1 volts across its terminals. So I think the meter resistance is not mentioned here. So this is the meter resistance. So now if I check, so this particular one is 0.1 volt. Take it across its. The external shunt resistance is asking. So we can take the shunt resistance. Shunt resistance. So is asking the shunt resistance. For the shunt resistance, take this expression. Shunt resistance. Question is meter. A 0 to 50 amperes moving coil ammeter has a voltage drop of 0.1 volts across its terminals. The external shunt resistance needed to range extension of this is 500 amperes. So very good question. So what to do now? RSH is equal to Rm by M minus 1. So this is I divided by Im minus 1. What is the meter resistance? Don't know. So first we can find out the meter resistance now. First we can find out the meter resistance. So Vm is equal to Im to Rm. So this is a 0.1 volt. Em is 50 amperes. Rm. So 0.1 by 50, that is 1 by 10, 1 by 500. 1 by 500 means 0.2. Use a calc here. 2 milliohms. Two into 10 power minus So RSH is equal to Rm by this. So this I can take it as 2 into 10 power minus. Capital I is 500. Im is equal to 50 plus 1. 500 divided by 50. 2 divided by answer 0.22. So I am getting it as 0.222. The right answer is 0.222. This is the right answer. Okay, dear. So these are the different versatile questions. The different versatile questions on the meters. Many topics I can discuss in the live class. We disappointed with the YouTube sessions because getting the students in the YouTube sessions, the English channel is very clear. So to develop the content here on the YouTube channel, so all the students of English following, they can attend regularly these sessions. I'm not teaching any marketing, I'm directly teaching the content. So after the session complete also, you can see the session and you can give the live comments on the particular session. That's it. If you have any doubts, you can ask me in the next coming lecture. Okay. Thank you one and all. If you have any doubts, you can ask me in the live, and you can collect these notes also. Notes is also going to be available. Thank you.